Hi, and welcome to the Department of Electrical and Computer Engineering. We are located in the heart of Centennial Campus in Engineering Building 2. Our curriculum is constantly changing based on input from industry professionals, so our students have the right skills to land jobs across the country post-graduation. We are top 10 in the nation for annual research expenditures. The average annual salary for our undergraduate students is around $73,000. We are ranked 13th nationally by graduates hired in the top 25 companies in Silicon Valley. If finding solutions and creating solutions to problems interests you, electrical and computer engineering may suit you. One thing we talk about with our students are the grand challenges of engineering in the 21st century. The grand challenges focus on 4 main topics: sustainability, security, health, and joy of living. One example of sustainability is solar energy. A group of ECE researchers created a cheap but high-effective solar panel using off-the-shelf components to create a solar panel that's economical for all. Electrical and computer engineers use bold thinking to find new ways to save lives in unique and unexpected ways. One researcher, Alper Bozkır, and his team found a way how to save lives with using roaches. Essentially what they did was created these mini backpacks with straps onto the backs of the cockroaches. What they did with these backpacks was use them to send electronic impulses to the cockroaches' antennas. This was a way for them to guide the cockroaches through a disaster zone to try to find survivors and hopefully save lives. They also used drones in the air to help guide the first responders to those people. This was a very unique way, using electrical and computer engineering to save lives. One decision that could be a tricky one is deciding between electrical engineering and computer engineering. I'm going to break them down for you, but let's start with what they have in common. Both programs follow a common core of coursework like physics, statistics, mathematics, and chemistry, as well as digital electronics and computer programming. In the electrical engineering curriculum, you're going to focus on electromagnetics, control systems, and communication. For the computer engineering program, you would focus on programming, computer architecture, and networking. Often, electrical and computer engineering can work together hand in hand. An example of this would be a mobile ground robot. For the robots are powered by a motor, and that motor is powered by a battery. The motor is what an electrical engineer would be creating. Robots would need the ability to sense what's around them to move, using cameras, radar, laser range finding, and more. The design of those sensors would typically be done by electrical engineer as well. At the heart of a robot is its computing system. This essentially creates the robot to be able to do everything it has to do, as well as think on its own. This is what a computer engineer would be creating. One common question we get is, what's the difference between computer science and computer engineering? And we'll break it down for you. Computer scientists concentrate on the computational process at an abstract level, rather than how it's accomplished with silicone and metals. On the other hand, computer engineers will be focusing on computer programming and then applying that to physical action. Let's review a little bit about the academic requirements for an ECE student. Year 1, ECE students are working on their CODA requirements as well as other ECE degree requirements. In Year 2, students begin to work on 200-level ECE classes as well as upper-level physics and calculus classes. In Year 3, students will begin to work on their 300-level ECE classes as well as other GEP requirements. Finally, in Year 4, students will work on their ECE electives, 400-level ECE classes, as well as senior design. Senior design is an opportunity for our students to work with industry professionals to create solutions to real-world problems. In senior design, it's a 2-part class. In the first part of the class, students are working on designing their initial prototypes. In the second part of the class, the students are working on making that prototype come to life.
So our project is Project 15, continuous monitoring of CO2 production during yeast fermentation.
We are the handheld non-invasive cocoa bean moisture meter.
Our project brings a mesh network solution to the IoT pool management systems.
Based on the Internet of Things. So the Internet of Things is great, but if you're outside of the network range, then your things don't work. And so our project is effectively extending that range with a Bluetooth mesh network.
Alrighty, we are Project 22, the Assist Tech demo. So our project is to create an off-the-shelf device in order to display all of Assist current research, which is in environmental monitoring, health sensing, as well as energy harvesting.
The problem that our project was solving is the fact that for many home fermenters, this is not their day job, and monitoring the fermentation process is a pretty labor and time intensive thing to do. And with our sensor, we allow the user to simply put the sensor on top of the fermentation vessel and walk away and be able to monitor the batch from their phone anywhere they have Wi-Fi.
We had to do K through 12 outreach events, so we went to Washington Elementary and talked to a 3rd through 5th grade class, and we just demonstrated all of our products, got some feedback. They really interacted very well. As soon as we told them that they had to have some temperature difference, they started rubbing their hands together and started creating a different type of temperature so that they could light up more LEDs.
The hardest challenge that we faced through the overall project would have to be the software. Getting our Arduino IDE code to communicate with our Python code was a little bit challenging.
Well, we've learned a lot about project management as well as the technical side of things.
So figuring out how to run our infrared sensors, Wi-Fi transmission, and microcontroller off of a reasonably sized battery to fit into a case that can sit on top of a fermentation vessel. That was a tough challenge, and so our hardware reflects that, and that we're pretty proud that we came up with that solution.
Our ECE students have many opportunities to get hands-on experience. One is through undergraduate research, where students work alongside faculty to see what they're doing and how it's applied to the real world. Another opportunity is co-ops and internships. These are great ways to get paid for working in the industry, figure out what you like and don't like, and see what part of ECE is going to fit you best. Another way to get involved and meet like-minded friends is to join one of our ECE organizations. We have organizations that run from pack motorsports through underwater robotics. Also, we have a student organization for our student ambassadors, as well as our Honor Society, which is HKM. I'm currently sitting in one of our 2 makerspaces that we have here at Engineering Building 2. Our students use these makerspaces to create projects for their classes, work on labs that they have in class, and also work on any personal projects that they may want to accomplish. Our makerspaces have many tools available, from ShopBot, the Wazer. We have 3D printers available, as well as hand tools for our students to use. Now let's step away for a moment, far away.
My name is Christina Cook, a double alum from NC State ECE, and I'm greeting you from the International Space Station. My journey towards fulfilling my dream of being an astronaut was not an easy one, but following my passion, pushing the limits of my personal boundaries, and having the determination to do what scares me has paid off more than I could ever hoped. I got to contribute to the program that I love so much by stepping out into the vastness of space on my first spacewalk, and by working on some of the coolest science experiments that test the limits of what is possible.
My name is Jeremy Gibson. I'm from New Bern, North Carolina. Born and raised. I graduated North Carolina State University with a degree in computer engineering in May of 2003. I've been here just at 15 years. I just passed my 15-year anniversary at NAVAIR. I'm currently the branch head of the electrical power and wiring group for all of our FSTs that oversee electrical power and wiring for multiple aircraft platforms, including our V-22 and H-53 platforms, which you're here for. So I had no clue what I wanted to do coming out of high school. Excelled in the math and sciences, but I had no idea what that led me to do. So somewhere along the line, I had made up my mind that I was going to work in computing systems of some sort. And I honestly thought that would lead me down an IT path, but I had the prototypical behavior as a young child of taking everything apart that you hear from engineers. I couldn't necessarily always put it back together, but I tried. Duct tape and super glue fixed everything. So I think that when I fell in love with the curriculum at NC State, that's what led me down this career path. And I've loved it ever since, never looked back. So.
You'll be proud of achieving the things that scare you. You'll be proud of becoming the person you imagined yourself to be. You'll be proud of the people around you. And most importantly, you'll be proud to be a graduate of the Department of Electrical and Computer Engineering at NC State.
If you have any questions about electrical and computer engineering, feel free to send us an email at ece-undergrad@ncsu.edu. We'd be happy to answer any of your questions and further that conversation to see if ECE is the right major for you.